Hello, everyone. How are you doing? So, are you ready to have this session that we are going to have today about how to learn to deliver robotics classes remotely to your students? So, I hope that you are ready, and we are going to have a very practical or tactical in some sense. So I'm going to provide you the tips that you can do, not only a strategy, but also the tips where you can go and do. Okay, so I hope that you are ready. So let me see here, because I have a lot of things here on my screen. And let me see. So yes. So how is it going to go? So I'm going to go through some slides here, and along the slides, I'm going to provide you the tips. And at some point in time, I'm going to provide you some links, and then I will copy those links into the chat so that you can get it later. But in any case, don't worry, because you are going to have this video later after this webinar, and then you will be able to rewatch it again in case that something is missing, some link is missing. So it will be there on the video for you for retrying later. Okay, so I'm touching here the table, and everything is moving around. Yeah, okay, so great. Then by the end of this session, we are going to have a Q&A session, so you can put your questions related to the topic of today. Okay, so don't ask me about how to do the octomap for Move It, so to avoid obstacle avoidance, the arm or something like that. Okay, that's for another session. Then let's go. Let me share with you the presentation with all the points, okay? And then the subject. Remember, the subject is to get ready to teach about robotics remotely for the fall of 2020, of this year. And let me switch to my here, the slides. Right, so before anything else, I would like to start by clarifying for who is this webinar. Okay, so this is not, if you are learning ROS, that's okay. So this is not for you. This is for professors, teachers, teacher assistants that need to teach to undergraduate or graduated students about robotics. And maybe you are thinking you are preparing your robotics course for the fall of 2020, and then you are trying to get some ideas because you need to do it remotely. And this is because of the reason of the COVID-19, right? So for all of you that match those criteria, is this webinar that is being prepared. If that's not your case, you can stay, okay? So I'm very happy to have you here. You can stay if you want to learn something new, get ideas for your future, whatever, so you are welcome also. Yeah, but I'm clarifying for who is the message that we are delivering here. Then when I say about robotics, what I am talking about, I'm talking about all of you teachers who are teaching any of those subjects that you can see on the screen. That's about robot action and perception, arm kinematics, mobile robotics kinematics, robot dynamics, motion planning and control, robot navigation, even computer vision, or even ROS. So if you are doing any of those classes, this webinar is for you. And let me clarify it again, okay? So I'm not talking for people who is thinking about robotics, like building robots. If you want to do a class for building robots remotely, that's very difficult. There are some solutions, but this is not what we are talking about here. What we are talking here is this kind of thing where you are actually programming robots. So you are learning about the behavior of robots, how to make robots interact with the world in order to do things, to capture things from the sensors and send to the actuators to do some actions. So basically that's the purpose. And let me go back to the slide of before. So those subjects that you have here are basically related to that, to make a robot which is already built interact with the world in order to do some tasks. Okay, so that's the goal of this webinar. And then for all of you who are thinking, okay, so who are you that can teach us about that? So my name is Ricardo Tellez, and I have been teacher for several years already at the University of La Salle here in Barcelona to undergraduated and also graduated students on the Masters of Robotics about ROS and robot navigation. So what I'm going to share with you is all my experience along those years, but especially how I delivered this last semester class, that we were confined, right? So then is where I prepare all this system to deliver and provide a practical class to my students, so that it's not just showing to them some slides, and so on, and explaining, talking, and so on. But I also provided to them a lot of experience with both simulated and real robots. So I'm going to explain you how I did it, and how you can apply that to your case, right? Let's go. Then, so the subjects. So what we are going to learn in this webinar. First, what you need in order to teach robotics remotely is how to teach the theory. So that's the easy part of the webinar. So how to teach the theory that you need to teach about arm kinematics, about robot control, about, robot navigation. Okay. Then I'm going to show you how to provide practice to your students, so that it's not only slides, as I was mentioning before, and also how to provide hours support, so you can provide answers to the students after the class. So once the class has finished, and then the students, they are practicing, they are reading, they are studying about your subject, and they have some questions. So how can you manage that? And also how to evaluate the students. This is very important, and especially in this situation, it's a little bit difficult. So I will tell you the way I did it, okay, in order to evaluate and try to avoid as much as possible cheating. Okay, then let me tell you that we are going to do anyway a hands-on on connecting to a real robot. So during this webinar, we are going to do a real robot connection. So I'm going to show you how I do it, and how my students also did, but also I will invite a couple of you if you want to try and connect to one of my robots that I have here, which is the one that you can see there. That's the robot, is the ROSbot robot made by company Usarion. And this company, very gently, they allow us to use their robot. So thank you very much to Usarion for letting us use their robot. And then I have it here. So it's behind this camera. You're going to see in a minute. Actually, I can show you this. Let me see right now. So I have to switch to the other camera that we have. So now you can see beside the slides, the robot, the ROSbot. This is the real one, which is now here on my space. So you can see that this is real. I'm putting my hand here. Hey, hello, hello, hello. Okay. So yeah, so you are going to connect, if you want, and control the robot here in some minutes, if you stay with me, okay, for doing this demo. Okay, so let's go. Let's start with the first step. Remember, teaching the theory, providing some practice, providing of hours support, and then providing an evaluation. Okay, let's go for the first one, teaching the theory. Well, for this is very simple. For teaching the theory remotely, you already know how to do that, because it's very likely that you have already done. But I just wanted to state the basis for the people who is the first time. So maybe you have already done on the previous semester, but some other people will not. So let me go to the basics. First, you need to have your teaching material, which is a slide, or it's a video, or something, whatever you are showing your material, like the one that I am showing here to you. So what you are going to do is to have a platform where all the students are going to connect at the same time, the same way as this remote webinar that you are attending, right? So you can be thinking about yourselves as the students, and I am the teacher right now. Then that's it. So you only need a platform. It could be YouTube if you want. That's okay. Like we are having here right now. Or in my case, it was the university itself which provided another platform. So I have to log into that platform, and then all the students, they will log in, and then I will share, like I am sharing here with you the slides. Very, very easy. So basically that platform that you are using, it must allow sharing the screen and have a live chat. And this live chat, I really recommend you that allows both things, mic chat and written chat. So for now, for example, in this platform that you are now, so you are in YouTube, YouTube only allows now written things. So you can only write me questions or comments or whatever, but you cannot tell me something, right? Then, because YouTube is like this. But other platforms, they do allow to have also the mic. So the students can connect their mic and then speak the questions. And that is very important because sometimes if you are explaining a complex subject, just writing down the questions doesn't allow to make the connection and to make actually express the doubt, or even for you to understand what is the problem in the student. So the student needs to express that with words. So that's why for me it's very important to have also the mic. It's just the last resort, okay, if you want it, but it's very convenient to have it. Then in my case, as I mentioned, there was a platform which was provided by the university to me. So they already organized that, and they say to all the teachers, go there, all the students go there. And you can manage like this, okay? But in case that your university doesn't provide you one of those, then I recommend you the very typical one that you are probably know how to do it, which is the Zoom application, right? So you know about Zoom. If you don't worry, you're going to know for sure. And Zoom is just this platform that I mentioned. It's an application that you have to install, very easy to install in your computer, and your students also have to install. And then you can share your screen like you have on the left-hand side here. And also you have a view of the camera of every one of your students. Then you can see your students, and your students can see you, so you can change between one or another. Then here you have a link that I found. It's quite interesting. So let me write down this link on the chat. So I'm going to write this link here on the chat, so you can have it's a tutorial for setting up classes on Zoom. It's a series of videos that I found on YouTube and that you can use for learning how to use Zoom in case that you don't know yet. And that's quite simple. It goes step by step, and it shows you all the options and so on. So that's interesting, so in case that you need that. Okay, so that's all. That's for the first option, which is teaching the theory. Remember, is you need your teaching materials, the slides, and then the platform to deliver that and communicate with the students in the real time, like in the class, like right now we are doing here. Then sharing a screen, check. A point here. In sharing a screen, it's very interesting that is the teacher that can share the screen. For example, now I'm sharing my screen with you here on the slides. But also it's very interesting that the students can also share their screen with you, because sometimes you will ask them to write some programs and do some things, and then it will not work. So you need to see what is the problem, so they can share with you the screen. Okay, so far so good, right? Then this is for the teaching the theory. Then providing some practice is the next step. And providing some practice, I mean to make the students apply what you have been teaching during the theory. So in my case, I do not believe about only do not believe, understand me. I don't like at all learning just by reading and doing some equations. So how I really learn, and I learn faster, is when I apply. I have the necessity to do something, and then I figure out how to do it, and then I do it in the real thing, let's say, to solve the real problem. Then in robotics, this is especially necessary. It's very, very important that you provide this practice to the students. And then let's see how we can provide that in robotics. Well, you can do in two ways. You can provide practice in robotics. Is one, by using simulated robots, or two, by using real robots. Okay, let's see both of them, and taking into account that we are in a confinement situation. Okay, so you are going to teach this remotely. Okay, so I'm taking into account that this very important point. So what does it mean? That you cannot set up the computers of your students, right? Because they are somewhere else. You don't know. You can provide instructions and so on, but you cannot be there for them, right? So that's complicating the things a little bit more. So let's go first about how to provide practice by using simulated robots. And it's quite convenient to use simulated robots, because you can provide different types of robots to the students. So if you are using real robots only, real robots are cooler, are super cool. We like them a lot. That's why we entered to study robotics. I suppose that's my case. And we want to work with real robots. So I'm not saying no to real robots, but in some situations, it could be very convenient to use simulated robots, because you can use a drone, you can use a wheel robot, underwater robot, a humanoid robot like this one. And then you have access to all these kinds of robots simulated, so you can learn a lot. And then let's go for the simulated robots. How can you provide a simulation-based practice to your students? So then, of course, so for me, there is no doubt you have to go straight into ROS and Gazebo as a simulator, because it's easier. So Gazebo is more integrated with ROS, so it will give you less headaches. Then you have to go to ROS with Gazebo. And then, in order to provide ROS and Gazebo for the simulations of robots in Gazebo, then you need to install all that in the computer of the student. Then you have, in order to provide this installation, you need you have several options. One of them is install ROS on the student's computer. So you make the students install in their computers ROS. And for that, I have this. This is the typical thing. And I have here the typical link that I'm going to copy also. And oops, sorry, I messed it here. Let me do it like this. Okay. So how to install ROS. This is the official source, okay, of how to install ROS of the creators of ROS, Open Robotics. So you can make your students go and do that. The advantages is that they will have ROS in their computers. The disadvantages, it's difficult. It's difficult for a class that they are able to follow this in their computers, especially because many of them, they have Windows, they don't have Linux. They may be using a Mac, like the one that I'm using here today. So installing ROS, this is making the installation a lot more complex. And then you and the students are going to suffer a lot, as well as wasting a lot of time. So it's an option you have to consider. Okay, so I have done this in the past, and we managed as we could, and this is an option. The good option is that this is for free, so no problem. Then a second option will be to provide a virtual machine to your students with already ROS installed. So that means that it's easier. So this virtual machine will be, you prepare the virtual machine with ROS, and then you send by, I don't know, by a Dropbox link to all your students, so they can download, and then they only need to install the virtual machine software in their computers, and then get this virtual machine instance with ROS that you have prepared and put it inside. That's a lot easier. I know it sounds like a little bit complicated, but it is not. It's very simple, because installing the virtual machine, the home virtual machine, the software for handling virtual machines, this is an application which exists in Mac, in Windows, in Linux. So it's for all the system. It's very easy to install in the computer. It's like another app. And then they only need to open this and then introduce there inside your virtual machine prepared for ROS. So here I tried to figure out one already made virtual machine with ROS Kinetic or ROS Melody, but I couldn't find it. But instead I found this video that teaches you how to create your own virtual machine with ROS, so that you can provide this to your students. So I'm going to put this into the chat, how to create a virtual machine with your preferred ROS distribution. So in this video, you can see how to do that, and you can learn. So the advantages of this is it's easier to install, because it's still some steps, and then some students will fail, they will have problems, they will not understand, but it's a lot easier than the installing directly ROS in a Linux system, especially if they don't have a Linux machine, so they have a Windows or Mac. So that's interesting. Then it requires some work on your side, because you will have to prepare the virtual machine. Then another more modern version of this virtual machine is to provide a Docker instead of a virtual machine. So the Docker is better because it's already made. So you can go to this address, and then, you can do a Docker pull ROS, and that's all. And then you get your Docker in your machine. Then this Docker is a little bit more abstract, more complicated, than the virtual machine, but is more modern and is more powerful than the virtual machine, because these Dockers, you can update them, and then your students can update remotely also, and they can have different versions very easily because they are already made. So yeah, so it's more powerful than the virtual machines, and it also is the trending way of going. However, it's a little bit complicated because it requires you to manage, you and your students to manage Docker, to understand some Dockers and how to launch a Docker, how to get inside, and etc., how to download it, and so on. So it's a little bit more complicated, but it can allow you, by using Docker, it allows you, like the virtual machine, to have ROS in any other operating system, like Windows or Mac, without having to install another operating system. Great, so let me write down here this link also on the chat. How to get Docker ROS Docker images. Okay. So far, so good, right? So we are going okay. I don't see any complaining here, so I suppose that everything is working fine. Great. Let's go. Then the final solution that I'm going to propose you is to use a web-based environment. And this is something that we have built at the Construct. So at our company, we have built in order to avoid all those things. So we have created this Robot Ignite Academy that is a web-based. What does it mean, a web-based? It means that it is already on the browser, so you don't have to install anything. You don't have to have a Docker, a virtual machine, install Linux, nothing. Just point to one address, which is this one, Robot Ignite Academy. So let me share with you. So I'm going to change here, and share the screen of the, let me see here. Okay. Okay, too many tabs. Okay, here it is. Then, yeah, so, well, here is our academy, which is the Robot Ignite Academy. And then here we have many courses already there. And what does it mean, the courses already there? That it means that we have already created even the material. So the slides are there, so you don't have to do it. And for many different subjects, in robotics, in ROS, manipulators, machine learning, and vision, and so on. So let me show you about this one, basic kinematics of mobile robots. And then when you open that course, you get this screen here. And then on one side, you get the slides, let's say. So it's the teaching material, right? But our teaching material is always tied to a simulation that you have here, which is a gazebo simulation, which is already provided also, and is on the browser, so you don't have to install anything. You can enter and enter on the Academy and start doing this if you want. And then, so we have this development environment where you have to develop, the student has to develop the steps that are indicated here. So it says, so take this, create this file, create this program, then launch this in order to spawn this material. Then you are going to get this. And so in this case, it's for the frame and representing rotations in the kinematics system of a wheel robot and so on. So you get all this, and then you get the results here directly on the simulation. This is something that we have built, and we really consider that this is very cool and very easy for teaching quickly to your students. That's the method that I have used at La Salle, okay? So my students were connected here, also each one with his own account, and they were following at the same time as I was explaining. So I was following this, explaining this in my own words, and then at some point in time, they have to do an exercise. So there is an exercise, and then I put them to do the exercise. So they have to do here and then do, I don't know, a topic list. And they have to discover the topics and then make the robot move and so on. So ROS topic, pop, CMD bell, then it's a twist. And then let's make the robot. So let's rotate, for example. Okay, so now the robot is going to rotate here, right? So, well, you can see. So that's exactly how it works. And in this case, it's for basic kinematics, but there are many other courses here that you can check. Right, so that's this option. Let me go back and stop the screen share and share again the slides. Again, slides here. Okay. Then that's another option. Okay, so remember, this is in order to provide practice with simulated robots. So I have indicated you how to install ROS, how to provide a virtual machine with ROS. If you don't like the installation, then have to provide how to provide a Docker and how to use a web-based environment, which I didn't actually copy this link to you, and let me put it on the chat. So Robot Ignite Academy, it's this one, just in case that you want to do it. Okay, so each one has its own advantages and drawbacks, so it depends on you which one you would like to use. And here we can see Jack Silverman that says, nice, Ricardo, as usual. Thank you, Jack. Yeah, Jack is one of the teachers at one university, which is actually using our academy for teaching their students. And then Agustinus says, can the step of tutorial install and create a virtual machine, Docker, etc., send to email for more detail? Thank you. Yes, so after we finish this live class, we are going to send you to all the registered people on the webinar. So you're going to receive this PDF with all the details. I'm just putting them here just in case that you miss some case, or you miss the PDF, you miss whatever, so you get it there. Okay, you buy multiple things. Okay, let's go. Next thing is, let me remind you that in case that you're interested on on this system. Of course, I am very proud of this system because it's the one that we have built with a very specific purpose. But then if in case that you are interested and you would like to know more, you would like to do some demos, have some demos of different courses and so on, then please take this link and then book a meeting time with me, and then we'll have a chat and you can ask me your questions and request me for a demo or so on. Meet for a demo. Whoops, what happened here? Let me see. Meet for a demo. It's B here. Okay, that's my agenda. So you can book me there. Okay, so let's go to the other option. So far is about, let me go back some slides here to providing some practice, right? And remember that we mentioned two options with simulated robots and with real robots. So I already shown you how to do it with simulated robots by using ROS and Gazebo in different setups. And now let me show you about using real robots, how to use the ROS real robots to provide some practice. And of course, I'm talking again about ROS-based robots, right? Because ROS-based robots ROS for me is the standard in robotics, and it's going to be even more adopted in the close future. So I believe that any roboticist needs to know about ROS. So that's why I consider ROS as the preferred tool for teaching practice. Also because ROS provides a lot of advantages, okay? We are not going to discuss that here, but just let you know that we need to use ROS-based robots. Then provide ROS-based robots with real robots. I'm going to provide you with two options. The first one that I have found is to provide a real robot to each student. So if you have that chance, because I don't know, maybe at your university, there is a fee that the students have to pay, and then you can afford that for each student. Then in that case, then I would recommend you to provide them this simple robot, which is called the JetBot, which is a two-wheel robot equipped with a camera and with an NVIDIA Jetson Nano board. That means that you can install ROS inside there, and then you can even do deep learning things if you are interested on board the robot. And you have a camera to detect the obstacle, the objects, and whatever is around the robot. So to build this robot is very simple. To build it, very, very simple. So anybody can do it. You only need to buy a couple of things, the base system, and then the additions for JetBot that come in a different part. So there are two links here. Let me copy this and provide you. And it's around $220 for the whole robot. It's around there. Okay, so if you want to build the JetBot robot, then you have to buy this. So those are links on Amazon. Oh, so everything was mixed. Sorry, yeah, I don't know what I did because, okay. Okay. So, oh, okay, that's nice. I didn't know about this feature. Okay, so, well, let me write it down again. Build the JetBot robot. So you have here, one, the base system, and two, the additions. So now it's more clear. Oh, okay, it doesn't allow me. Well, more or less I organize somehow there. Then we have here Changfang Zhao, who says, the Robotic Night website is pretty slow on my personal account. Will subscribing vocally make it faster? Okay, Changfang, it's very, so by your name, I'm not sure, okay? Please don't misunderstand me. I think that you are from China. So if you are from China, then there is a problem in there because of the firewall, and then it goes slow. So in China, our system goes very, very slow. For the other cases, it's not. So I'm showing you right here, so how it works, and then it's not going slow at all. Then it's not going to change if you subscribe for college. It's not that the problem. The problem is the firewall that is emitting. And then you say you are from UK. Okay, then if you are from UK, then it shouldn't go slow. Okay, but then it depends on what you mean by slow. So let me share again here. Stop sharing and then share again the window here with the Robot Ignite. So I don't know what you mean by going slow. So the speed that you can get is this one. You can see the robot here moving, then changing from a unit to another unit. Then that's what it takes for changing from one unit to another. So here we have already loaded the new lesson, here the new lesson with new values, and here the simulation has changed, so that is why it's reloading. And here the terminals, they are already ready, so that's the speed. If for you this is slow, then that's the situation that we have. So we cannot go faster than that. If you mean about doing ROS topic, tap, then the autocomplete, let's say ROS topic pub, and then tap, CMD-vel, tap. Okay, there is no CMD-vel. Let me see, ROS topic list here. So we don't have CMD-vel. We have encoders here, or left wheel command controller. Okay, so ROS topic pub, then let's say left wheel controller command. So that's the speed that you can expect here. See, tap, and yeah, then 0.3. I don't know what it's going to do because I don't remember what is this command. Oh yeah, it's for the joint, right? Yeah, from on the left, right? So that's turning here. So that's the speed that you can have. Then we have some questions also from Jack. He says, in my opinion, one of the great advantages of the Robotic Night Academy is not just it has ROS and gazebo requiring internet connection and computer, but the class content on CBTs that they provide. Okay, it saves a lot of time, especially if you need to transfer your curriculum. Exactly. So thank you. Just as educator trying to help another. Thank you very much. Thank you very much for your kind word. I'm so happy that it's being useful for you, Jack. Thank you very much. And then we have Chang Fang. He says thanks. Then Jaxi says still that is what the virtual machine is doing for you. It starts boot load all the software. Then you get the GUI ready for you. Now, okay. Yes, and then it's exactly what Jack says. So it takes some time. However, we have some surprises for mid-August on terms of a speed, but I cannot tell you because I cannot promise. It depends on some things that we are just finishing, but it's very likely that we are going to increase a lot the speed. Okay, so but I cannot promise you right now anything, just letting you know. So what I'm telling you is the quality is what you see right now. Okay, so let's continue, guys, because it's getting only for that subject. And my main goal, my main aim here is that you learn a lot, okay, about what we have done, of course, because I am proud, and then I would like you, really, it's going to help you a lot, but also I'm providing you with many other options that you can test, and then you can adapt to yourself, so and select the best that suits you the better. Okay, so that's my aim here today. Then we were talking about the real robot, and then I provide you this one for JetBot, and it's quite interesting. So if you want, if you can provide this to your students, then go for it. It's a very nice robot. And then the other one is to provide a remote lab. That this is the thing that I did with my students. So what I did is to bring this robot. So I asked the guys of Usarion, hey guys, can you send me one ROS bot so I can use with my students? And they they send that for me for free because they are very cool guys and are my friends. So then I put this on my home. So the picture that you can see there is my home because I was confined at home. And then I put the robot there, and then I added an external camera. And then what we did is to use our online academy system to connect to the real robot at my home. So then by taking turns, each one of the students was testing their code in the robot at my home. So first there was one, then he tested, we see, oh, there's a problem, blah, blah, okay, try to do this, and I think that you have this problem on your code, try it again, then next student, and then we were taking turns by doing this, so each one was connecting and testing on the real robot, and then crashing against the plant there, and of course, those things happen, yeah, because they are testing programs. But it was very cool and very funny experience. So let me show you how we did it, and let's do it together here, okay? Then, in order to provide this remote robot lab, what do you need? First, you need to have a robot with internet access. So the robot that I have there, it is now connected to the Wi-Fi of this environment, of this place. This is the construct headquarters that we are now. And here, so the robot is connected. So the robot itself, it can ping Google, for example. Right? Some people doesn't want to allow this kind of connectivity, then it's not possible. If you don't allow that, then of course they cannot connect from the outside, right? So first requisite is this one. Second, you have to install a server in the robot. This server is a server that we have created, and it's very simple program, a very simple process to install in the robot. So that's some work that you, the teacher, has to do on the robot that you have, and you want to provide access to your students. So the situation is that you have the robot here, and then you have so let me show you the robot. So here, cam is this one. Yeah, so the robot that you have there, it's a robot that you have in your lab or you have at your home if you are at home. And then you have full access as the teacher, but not your students because they are in their own locations. So you are going to be in charge of installing a server in the robot. Then you need to add an external camera. So that's what we have here. You see, we have the camera. Let me come back here just to make it understand. So here is the camera. First, camera number one. Hello. So you can see me. Let me put it like this. It's easier. Hello. Okay, so this is the camera that I am using for watching me. And then we have another camera, which is an external camera. That is the camera which is used to show the students what is the robot situation. You know, it's like they were here with me. So, and this is necessary. You need to have both, yeah, because you need to, your students need to see you and then see what is happening there. So let me just come close to this camera. So here you can see, and then I'm going to move here. So you see here this is the other camera that this is pointing towards the robot, which is over there, right? So that's the setup that we have done it here today for this live class. And going like this. Okay, so yeah, so that's clear, right? So you need another camera to show the status. And what else? Let me come back here. Yeah. Then what else? So then, yeah, so then you need to connect to the real robot, not you, sorry, the students. They will connect to the real robot by using the ROS DS, the ROS Development Studio. The ROS Development Studio is a tool that we have here on we have this tool here on the, wait Wait a second, too many options here. So here in the Robot Ignite Academy, I'm going to go to the list of courses here. So that's the list of courses that we have. And then here on the panel, we have another option, which is the ROS Development Studio. Okay, so that's an option which is here for developing. Once you know how to develop, that you learn here how to develop, then you can go to the ROS Development Studio and then use this system. Let me see. Okay, so I have been disconnected for being here so long time, but I'm going to show you anyway. So this is the ROS Development Studio, which is an option here on the side of the Robot Ignite Academy, and those are projects that you are creating related to ROS. So here in this case, I have this project using the Usarion ROS bot. So I'm going to open it right now, and then we are going to connect. So I'm going to connect through this environment to the robot there, and then I will be able to see the laser, to see the TF and whatever, the camera and so on. Okay, so let me open it. And then in the meantime, what I would do is to ask you the ones that are there on the stream, if you are interested on doing this, also you would like to connect to my robot. So a couple of people that would like to connect to my robot from your own location, so you can experience what your students will do when you implement this system. Okay, so anybody, please say that on the chat if you are interested. So what I have done is to launch this project, which is a project with Robot Usarion. It's a project, it's a ROS project with Robot Usarion. Then once it is open, then it is going. We are going to be able to connect to the real robot. Everything related to the web browser, right? So it makes sense. Then let me know. Let me see on the chat if you are interested on connecting to the robot. Otherwise, I'm going to show you directly what it is, how it works. Then all those steps, in the meantime that I'm waiting for you, so all those steps, how to do that, how to implement all this, how to have the robot with internet access, how to install a server, blah, blah, blah. This is explained in this video, which is a 10 minutes video. It's very simple. So let me put it here. Then here it's how to set up a remote robot lab. So here is the link. Then I have two people here already that have answered. Felipe first, Nascimento Martins, and Andres Hernandez Gutierrez. Okay, very good. Then what I'm going to do here is, in order to show you how to do it, first I'm going to, here, this is still opening. Okay, it takes 1.5 minutes to open this one. But once it's open, then we can go fast. Then I'm going to share with you guys this ROSjet. So let me copy here this link and put it here on the chat. Okay, so let me see. I'm going to share with you. So here, this ROSjet, that is the one that I have open, that is opening right now. Then I'm going to share here, copy the link, and then I'm going to put this link into the chat here for Felipe and Andres. Okay. Then Felipe and Andres, you have to click on that link, and by clicking on it, you are going to have a copy automatically generated of this ROSjet in your ROS Development Studio area. So you're going to get a copy of my project. Then once you have that, then click on open. So we can be, and this is taking too long, so this is not normal. Okay, so here it is. Then once it is open, then you will be on this situation, the same one as I am here. So now it's loading the documentation. Yes, okay. So this is the documentation for that project, which is based on the Usarion robot. Okay, so now what I'm going to do is to connect. Remember, this is a development environment for ROS on your website, on your web browser. And we have here all the tools required to develop. We have gazebo simulations, we have terminals, we have IDEs for development. And what we are going to do is, before attempting any of those, we are going to connect directly to the real robot using this option here on the top. Then for doing this, you only need to press this button here, connect to real robot. Okay, so then after a few seconds, a new dialog is going to appear here that is going to ask me for a couple of data. Then this data is the data that the teacher has. This is a data that the teacher has. So in my case, it's myself. So I have this data. It requires me the robot name and the robot URL. Okay, so I have to provide this data to my student, to the student that is going to connect in that moment. And how do I do that? Well, then I have to open another tab and connect to my robot server. Remember that one of the steps was to install a server on the robot. Okay, so now it's time to access that server, which is always located in the address of web address of your local network of your robot. In that case, in my case, is this one that you can see. As you can see, it's a local address. So none of you can access this address. None of the students can access this address. It's only me, because I am on the same network as the real robot. Then here I have the device name, which is Usarion. And then I need the robot URL, which is empty. In order to do that, I'm going to turn off and then turn on. And now the URL has been generated. So what I'm going to do is to copy this Usarion and go to the ROS Development Studio and provide here the robot name, Usarion. And then I will copy this robot URL and include here in robot URL. Then connect. By doing this, my browser is going to connect to the real robot. Now it's done. So connected to the robot, it says Usarion, so I am connected. Then what I'm going to do now is to open in Tools, open a terminal. And opening a terminals, and then I can do a ROS topic list and see, oh, sorry, I typed it wrong, ROS topic list. And then I should see the topics of the robot itself. And it says just a few things: scan and ROS out. Why so few of them? Okay, let me see. Oh yeah, so one of the controllers inside the robot has been killed. Okay, so let me launch it again. So this is the controllers inside the robot itself. So sorry for that. Okay, so I'm launching the drivers there. So now I'm going to do a ROS topic list. Now I can see all the topics in there: the TF, the odometry, the velocity, and so on. Okay, or camera, and so on. Okay, great. Now, so what I can do is to, for example, is to launch Arbis. So I can launch Arbis here. So if I launch Arbis in this environment, that is a web environment, in order to see the output of Arbis, I need to go here to Tools and select the graphical tools. So another window is open here, and it's going to show me now here the Arbis. Here it is. Okay, so here we have the Arbis, and here we can see the camera of the robot. So this is what the camera of the robot is watching, actually. And we have a problem here with the fixed frame. And let me put it, for example, base link. Oh, here then we have the laser that we have there for the robot. Then I can add, for example, the TF. So I can add the TF in order to see the structure of the frames of the robot here. And there are. Okay, so now we can also try to move the robot by opening another terminal. So here we have, this is the RBase window. And here we have the terminal. This one is the one that is launching the RBase. So I'm going to launch another shell, another terminal, and I'm going to publish. So let me check, because I think that something was killed. Yes. Oh, Common Bell is here. Okay, so let me type ROS topic pub on CMD Bell. So I'm going to provide a twist to make the robot rotate, minus R10. So now the robot should start rotating. Okay, but it's not, yeah. Okay, so for some reason, some of the controllers in the robot for the wheels, they have crashed, and I don't know why this. Okay, so this is something inside the robot itself. So it's about its drivers with the wheels. But you can, I think that I cannot solve that right now. I don't know why, but you can see that what is happening there is that I'm receiving on the web browser the information from the robot remotely. So let me put myself in front of the camera of the robot so you can actually see that is the robot. Correct. So here, hello, I am here. Hello, hello. Okay, so I don't know, I hope that you have seen how everything was changing while I was moving the robot. Then I hope that you understand that even if we cannot move it, it's another problem because of the drivers, but you understand how it works remotely. Okay, so now let's go to the guys who are there, who were, let's see, Andres. Okay, so Andres, what I'm going to do right now is to, let me stop here. So what I'm going to do right now, Andres, is to stop my connection to the robot. So let me apply here. So here, I'm going to stop my real robot connection. I'm going to stop, okay? So stop. Now, we are going to allow Andres to connect. So it only can connect one person at a time. And that's very cool because then it allows anybody, so it doesn't allow other students to interfere, the first student in any case. So let's go for Andres. So Andres, I can see that you are ready there. Then let me share with you. So you have to go and press on the ROS real robot connection, and then press on the connect to the real robot until the pop-up appears. Let us know when this is running for you, when this pop-up appears. So let me share, just to clarify, Andres, you had to go here and then press here real robot and then connect to robot, on, switch it to on. Then only once, then you leave it there working, and when it is running, then it will appear here a pop-up in the middle. Let me know when this is done. Andres. Andres, are you there? Which hardware? You say that it's asking you to choose the hardware. No, you don't need to choose any hardware. Are you already open with the project, Andres? So let's go again, Andres. So check my screen, okay? It's for, this information is for Andres and for Felipe. Yeah, okay, Andres. Let's go for Felipe. Felipe is ready, and he says, I am on add robot screen. Okay, so let's go with Felipe. And then what if we try with Liu Jun Lee also? Liu Jun, are you also, you would like to? Let me know. Then in the meantime, let's go with Felipe. So Felipe, you are ready? You are in the add robot screen. Felipe. Then, so you are here, connect to real robot. Then it should appear here, the element, the pop-up, add robot. Okay, so that's the screen that you are there. Okay, Felipe? Then in robot name, you have to write Usarion. So you write Usarion there. Usarion like this. Okay, so I'm putting here Usarion. Okay, robot name. The chat doesn't allow me to put just Usarion. Okay, Usarion. You have to put this in non-capital letters. Then, okay, you got it, Felipe. Then you are waiting for the web address. Then for the web address, I'm going to come here. I'm going to turn this off and turn it on again. So now I get a new, fresh, generated URL for you. So I'm going to copy this and put it on the StreamYard. Then you have to copy and put it there on the URL. Okay, so let me see and see if this allows us to put it there. Okay, so copy that and put it and then press connect. So then you put it that address here and then you press connect. I'm going to cancel because I don't want to connect at the same time as you. Okay. So let me know, Felipe, if you are ready for that. In the meantime, we have a question from Agustinus Magnutam that says, what about the student build a robot from ROS to real mechanic building and electronic circuit, construct to robot, and then the ROS software, infoware to implant the robot control list component? Okay, your question is a little bit difficult to understand, but I think that what you mean, Agustinus, is that about what about making the students to build one robot? Right? What is the... Then Agustinus, okay, stay a moment, Felipe. And then Agustinus, let me share with you this screen. So here in the Robot Ignite Academy, here we have a course, which is your first robot. Let me go down here. Your first robot with ROS. So this course is teaching you, if you go to the details, is teaching you how to build, create a simple ROS-based robot. So a robot from scratch with all the material list, how to connect, mounting the robot, and using Raspberry Pi, a camera sensor, and then putting the ROS controllers, as you mentioned, to control the wheels. So at the end, you are going to create this robot here and ROSify it. So that will make it work for you. So you can use this course, but in this case also, the students need to order the pieces because it's something that needs to be done. Okay, let's go back to Felipe. It says task done. Then that you are connected. So now you can do, for example, here, if you go to the problem is that I don't understand why this is the problem with real life demos. Okay, so it's a problem in the robot that has crashed the controller of the wheels. But you can do, for example, a ROS topic list, and then you should see the topics. Okay, in my case, it's not communicated with the master because I have closed the connection, but you should be able to see this list of topics, that those are the ones of the robot. So you can now, for example, launch the RBIS and then add you can add the camera. You can add let me do one thing. I'm going to put it here on the table. So in my case, this is gone, so it doesn't allow anymore. But you can connect to the laser and visualize the laser on the RBIS, or the camera and visualize the camera on the RBIS. So let me put it here, the mug in front of the robot. Okay, so then it says task done. So, okay, yeah. Then the problem that we have here is that we cannot configure here. Okay, so I cannot see your screen. Then in the case of a real student, then we would be able to connect to the screen of that student and see what is happening. So I don't understand what you say, because if it says task done, let me provide you, Felipe, let me provide you. Could it be that somebody else has been connected to the robot? Could it be? And then it has used, because one is one link for one single person. I usually provide this link through a private chat to that person, but we cannot do it here. So let me copy this. Okay, let me try if I can do a private message to you. Private chat. No, okay, I cannot do it. Okay, then guys. Oh, the URL is not completed, says Liu Jun Li. Liu Jun Li says that the URL is not completed, and that makes sense because this is because maybe it's YouTube that is providing you with that. Okay. Okay, so many problems with this. Okay, let's try then with, if you don't mind, Felipe, then let's try with Andres, that he says that there it is. So if you, Felipe, can go to the real robot and press disconnect on the real robot. I'm sorry, Felipe, I cannot debug more on that side. I cannot do more. The problem is I cannot see your screen and I can guide you. So, yes, I'm sorry, Felipe. Let's try with, yes, with Andres. So Andres, you go to the real robot. Let me share with you again. So application, yeah, so here, you go here, press real robot. So let me close my screens here so I don't confuse you anymore. Then real robot, then press on. In my case, I didn't press the off. Oh, okay, yeah. Okay, so let's try now. Real robot, connect to robot, press on. Then on the pop-up that will appear, you have to write Usarion with H. So robot name, where it asks robot name, then you put Usarion. And then when you press on when you have to put the URL, let me generate another one for you. Let me know when you are ready. Okay, so then, no, wait, Andres, you cannot try to connect because it's not going to connect. You need a URL yet. You need to data. So the URL is Usarion is for all the students, but for each student is a different URL. So you have to go here and generate another one. And this is because it's to prevent people from connecting to the other ones and doing a mess in that sense. Okay, so now if you have done connecting, then you have to go disconnect and then press again connect. Let's try to do it. The URL, okay, you are ready for that? Then I'm going to paste it there. So that's the URL. Then it ends in 650. So make sure that you have everything in there, because Liu Jun Li, he mentioned that the URL was not completed. So maybe it's being cut by YouTube. I'm not sure. So what I can tell you is that I didn't use YouTube for that, okay? Because YouTube is a pain with the links. And also it didn't allow me to share Task done. No, task done, no, is not possible. That's not the word. That's not the word. That's the same error with Felipe. That's the same error. Okay. Okay, so we cannot do more with that. So let's continue because we still have 2 steps to indicate. And then we need to go. I'm sorry, guys. We cannot do more. We have to move forward. So let me share again the application, the presentation. So in case that you would like to have this in detail, we can have a one-to-one session later, and then you can test this. Okay, so we have an exclusive one-to-one session. You use the link that I mentioned before. I'm going to mention later also, and then you will be able to connect, and then you will be able to see my screen. I will be able to see yours. We can chat and so on. So we can solve this problem, and you will see it's not that difficult. So having mentioned this, is the end for providing practice based on real robots. Now, what next means is what is next? What is remaining to provide to your students of hours support? Then in order to do that, the of hours support, what I propose is that you provide a forum. And then the students, they put the questions there in the forum. And that is very interesting if they put the questions on the forum, because other students can see the questions and the answers. So you can avoid, by using the forum, you can avoid answering the same questions all the time to different students. You know, like if you had open the door of your room, I don't know how to say in English, is where you are at the university, so your students can come and ask you questions, then different students can ask you the same question all the time. In the forum, it's better because you just post it there. And also, you can make somebody else to answer the questions. You know, you can have a teacher assistant, and then you say, hey, you answer the question in there. And also, those questions are going to stay for next year, for next semester, and so on. So you are saving work. Then, in my case, there was a forum already provided by the university in that platform that I mentioned before. But in case that you don't have that, or you are not that lucky, so you need to provide a forum, then the typical one, very good one, and simple also, and nice, it's called Discourse. Discourse is the one that we use, for example, in ROS. The ROS community has a ROS Discourse, and also our platform, the Robot Ignite Academy, has a forum based on Discourse where all the students can ask questions. So, for example, if your students are enrolled in the Robot Ignite Academy, they can ask us the questions to us. So you don't even have to answer the question, right? But in case that you would like to provide this forum for yourself, let me provide you this video that you can have this Discourse. This is a link to a video where you can have, if you follow the instructions, you can have this Discourse installation and running in under 30 minutes, Discourse installation. So this is for a local installation of the Discourse forum, okay? Okay, so that's it for providing of hours support. That's enough. Then let's go to the final point, which is about evaluating the students. And that's a difficult point because in this case, you had to evaluate whether they have learned, but it's a big problem now because they are on their own, at their own location, and it's very easy to cheat, right? Then how do I do that? How did I do that in the past? Is by creating exams based on doing ROS code. So if I had this those exams that I created inside the ROS Development Studio also, and then I provide those exams containing, in the Robot Ignite Academy, and they require the students to do some tasks on the robot. So if it's about mobile kinematic, then it could be about putting the robot on the frame, on the position number 34 of the frame of reference of the external camera. I don't know, just thinking about an idea. Okay, so you have to move the robot until it reaches that point. And then by doing this, they had to build something that works. And then you are avoiding this kind of ABC answering type of exams that is quite easy to cheat, right? In this case, they have to build programs, but not simple programs. They have to build ROS programs. Then when you ask somebody to write ROS programs, it's quite easy to see if they have copied those programs from somebody else, because the structure is going to be very, very similar. Then on top of that, what I did is to make them put some special random words in the places where they need to, for example, to create a package. So I think that I'm explaining very well. So what I did was to ask them to create a package, okay? So you have to create a package which is called my package. Then for each one of the students I was indicating, you have to create a package which is called my package, followed underscore your name. So every one of the students will have a different name. Then suppose, or surname, or I don't know, or whatever, any other thing that you mentioned to these guys. Then every one of those will have different packages name. Then I will say you have to create also a callback to capture the data from the sensor. And this callback has to be called my laser callback underscore my name, your name, sorry, your name. And then every callback will need to be different. Then they need to create another message. And this message is going to be called extra data underscore your name. So by putting this data, by requiring them to do that, then it's almost impossible that they are copying from somebody else, because if they copy, they will not understand where they have to modify this copied code in order to adapt to their own name. And even if there is one that you say, oh no, but those guys, they know how to do that. Okay, then they deserve to pass the exam, right? Because if they know how to modify the CMake list in order to change the name of the package, they know how to modify the structure of the program. So they know the subject, right? So then that's the way that I did it, by providing practical exams. And this has a drawback, which is that you have to correct those exams by watching every one of the exams one by one and testing that their code have been done and so on. So what I'm going to do right now is that I'm going to share with you one of the exams that I did. So it's a ROSJET that contains one of the exams that I did, a very simple exam, okay? But you can get an idea of that, how I did it. And by the way, let me share here, just a second. So here on the ROSDS, so one of my exams, let me see. Okay, so it wasn't with this user. It was with another user that I have here. Let me log in just in a second. So it's another exam, it's another user. So I can share this exam with you. I think it's going to be interesting for you. So exam, yeah. Okay, so those are my students. You can see here is the exam of Brian, the exam of Juan Alejandro, the exam of Miguel, Pablo. So those are, they send me afterwards they share that with me so I could evaluate it. And then this is the robotics master exam. Okay, so I'm going to share this with you. Wait, not that one, it's this one. So this is an example, and I'm going to put that on the chat. So exam example. So if you click on that link, then you will get a copy of my exam. Then you can open it afterwards, and then use it for yourself as an example, and then I'm showing there how do I evaluate. So I say, if you are able to create this, then you will win a point. If you are able to create the topic subscriber, then another point. If you made the robot do this, then you have another point. So you can evaluate based on that. Okay, and then so wait a second. Good news, we have Felipe that he has connected to the robot, not robots, just one, and he can see RBs, and he can see the laser or something else. Felipe, can you take a screenshot of your screen and then share that with us? With, I don't know, put it somewhere in Twitter, on Instagram, or something, and then share that with us on the chat. That would be great. But I'm super happy that you finally made it, Felipe. Good job. Then for the rest of us, let's continue. We are about to finish. So that's what I mentioned about that's what I did about the exams. Okay, so they must be about applying knowledge. I allowed the students to use their own notes and all the courses during the exam. So I didn't care about that because they needed to apply really and make it work. So if they didn't understand how it works, then having the notes and the code and all the things that they did during the class didn't solve anything. And that is for today. So let me jump for the conclusions. And the first one is that you have to start getting ready for that, because really, I think that the situation with the COVID is very difficult. I'm very worried about what is going to happen to humanity as a whole, because it's going to continue to this for some time, at least until the end of the years. I think that's my opinion based on the news. Okay, I'm not an expert at all. So for that, but what can we do? The only thing that we can do if we are teachers is to start getting ready, right? That's the best thing that we can do in order to deliver the best experience to our students. And then for that, I think that you have to start getting ready and thinking that this is going to be necessary to take some of those steps. So think about it and see if this information is useful for you, or you find another different way of doing it. Then I would like to also to mention that in most of the classes and all the classes that I have delivered to all the teams, all the groups of the students, they came to my class and 90% of them, they didn't know about Linux or Python. So because of that, we created those two courses, Linux for Robotics and Python for Robotics courses, which are completely free and which are on our academy. So you can provide those courses to your students if you want. So they will be doing this Robotic Ignite Academy method with the simulations, with the text, creating the programs and seeing the result, and learn the basic Linux necessary for robotics and the Python necessary for robotics. It's an introduction, okay? So it's not the whole thing, but it's good enough so they can learn ROS later and do things with Linux and so on. So let me copy those two links in case, and they are completely free, okay? So don't worry about that. So here, that will be like that. Great, and then let me see if there is something else. Yeah, so, well, that's it. That's up to here. In case that you would like to have a demo with me, you would like to try connect to the robot in a one-to-one session with cameras, both of us. So you will have a camera, connect with me, with Mike, and so on, so we can see that how it works. And then please book a demo. I have a pretty condensed agenda, so I'm very, very busy. So I need you to go through the agenda because otherwise I can trying to arrange a meeting together is taking too much time with so many people. Then let me put here my agenda reservation in case that you would like to have this one-to-one session, or you want to ask me more questions related to your own specific setup, your own solution. You don't have to ask me about this connection, okay? So, or the Robotic Ignite Academy. If you have any other questions, I'll be also happy to answer you about that. And that is all. Then we are going to finish here, but still have some minutes for questions. So let me know down on the chat if you have any questions, and I'll be happy to answer you. And so at the end, we have one successful connection from Felipe. That's very cool. That's very cool. And I'm sorry that we didn't make it with Andre and neither with Liu Jun Li. Okay, thank you, Jack. Thank you for attending. My honor that you attend here, and that you mentioned also that it was useful for you, the academy and so on. I still have to answer some questions to Leonor. So I know it's on my agenda and I'm going to do it, okay? So please give me some time, but I'm going to deliver that to you. Liu Jun, thank you very much for your comment. Any question? Changfang Chao also, thank you very much. Any question, doubt? No questions? So, okay, so it was clear then, I think. Then all the links, you get all the links, and in any case, we are going to send you those slides, as well as a link to the video where you can review and check any of the steps that we have done. So if there are no questions, I think that we can finish here. Andres, my pleasure. Thank you very much, Andres. Wow, we have been already here for 1 minute and 26, 1 hour and 26 minutes. Wow, that's it was fast. So, but I'm sorry about you that you had to wait so long time. Sorry. Oh, one question from Craig Robotics that says, do you have also recommendations for ROS manipulators? What do you mean, please? Do you mean about robot manipulators? Robot manipulators that you can buy and to provide to your own students? Then yes, I do have. There is one very cool, which is called Nerio robot manipulator, which is a small size like this, and then you can have on your desktop, and then it works with ROS. It's very cool. Then there is also from a company they use, it's called Rosen Robotics. They also build small manipulators that you can buy, and they work with ROS and with servos, with dynamic cell servos, I think it was. So they are small. You can put it remotely also, of course, as this one, and then they can be used. And another one is the Open Manipulator by Robotics company. The Open Manipulator is also another one. It's a small one that you can build. You can even print it in 3D and then have it, or you can buy the parts if you want. So, okay, Agustino says great info and great job. Thank you very much, Agustino. Anything else? Any other question? No questions. I think that we need to go to grab some coffee, right? Yes. Okay, so then, guys, we are going to stop here. Thank you very much. In case that you have more questions, don't hesitate to send me, book a time with me along the month of August, and then we can discuss it also. By the way, you can also put your questions on the comments below on the video that is going to be published in YouTube, and you are going to get to receive the link to that. Actually, it's the same link as you have, so if you are watching right now. Okay, so you can use that also to post your questions. Thank you very much. Muchas gracias, Felipe. Exactly. So thank you very much, and see you around the world. I hope that your remote classes are going to be a success. I hope if you let me know about your successes, and I will be super happy to know that you have succeeded and that it was this information, something there was useful for you. Okay, so thank you guys. See you around the world. Bye-bye.